How do you charge modern AGM batteries that require 14.5 to 14.7 volts until they take less than 1 amp of power in a modern dual battery overlanding vehicle that has an alternator putting out 13.8 to 14.4 volts? The answer is you don't.
Now we're going to do an experiment that hopefully will clarify a major difference between this and a split system. The DC to DC charging systems have a substantial advantage over how they treat the batteries and how they get maximum power out of them and maximum life expectancy. Now, it's kind of ironic that I'm using the National Luna dual battery monitor that comes with their split system, which is the one I used to use. It's the only piece I've kept. It's kind of ironic, isn't it? It does show both batteries on one scale, and I like that. That's why it is sort of tucked away in the console, just in front of the handbrake and up by the controls. So just on a piece of Velcro, I cut the wire in half and rewired it to meet my specifications. The secondary battery is here. This is the dual yellow tops. I've run them down to basically 12 volts just for this experiment. So they're down at about 80% depletion. We're in a safe zone. We haven't harmed the batteries, but it is down low. This is the start battery. I have also run it down to the point where the Jeep kind of now protects it at this level. This is more than enough to start the vehicle, but it is down at 12.3 volts. We're going to run an experiment. This is the dual Optimus yellow tops. This is the start battery. And we're going to plug it into shore power. So what we expect to happen and will happen is that the DC charger, shore power charger, is going to go and do its job and bring this up to full power. That would be 13.1 volts resting. The Optima red top can't go as high. It goes to 12.75 because it's a traditional battery, and that's why it works better for a start battery than the Optimas, the yellow tops and the blue tops would do, or Odysseys of similar chemistry. And it is currently sitting at 12.3 volts. What's going to happen is the charger is going to top the main batteries up, or the house batteries, and then with excess power, it's going to put them in a float charge and just basically maintain their charge. But it will take extra power at that point and divert it and top up and maintain start battery. That's a real nice feature. That will happen whether it's on solar power or whatever, because the system just manages the power in different ways. We're going to go ahead and put some juice to the batteries. This AC plug here is a twist lock plug. It just twists and opens. And what happens is that I can unplug the AC power from coming in, and this is where it's distributed to. I've just simply got the two cables coming into here. This one goes to the fridge. The National Luna, when it sees AC power, switches to AC automatically. This is really handy. There's no special brains required. It sees AC, it goes from DC to AC. I plug the vehicle in and it goes to AC off of DC, right even, and it doesn't miss a beat doing it. This is where our shore power connection comes in. It's a simple wall plug that we plug into a standard 110 plug, and it goes back to the wiring at the back of the panel that wraps around the fridge. It's pretty straightforward. Everything happens automatically when that is plugged in. And when we're not using it, we just tuck it behind the bumper and it snugs right in there. Doesn't cause any problems, doesn't rattle, we don't notice it. It just kind of slips in there into a relatively protected environment. Let's go ahead and connect the plug on the front of the Jeep to AC and let's watch what happens. Don't forget, we're 80% depleted on the house side and we are 50% depleted on the start side. Let's go.
CTEK Charger took about 3.5 hours to bring all 3 batteries back up to full power. We sped it up to about 3 minutes. This system has the capability to do this type of a charge profile, whether it be shore power, engine power, or solar power. The charger has 3 modes: normal charge, power supply, and recondition. And it goes into whatever was last used. You'll notice that the charge voltage has come up to 13.8 volts and it's still pushing 23 amps, but it's giving more resistance. So the CTEK is cranking it up. You'll notice that it's up to 15 volts and it'll stay there now until it takes less than an amp. At that point, the battery will be fully charged. You might ask, why 25 amps? Well, it's 3.5 hours to bring 110 amp hours back from 80% depletion. That's pretty amazing. And it's really nice to have, so when you need to bring them back, it doesn't take all night. It's really nice that way. And the other important thing to remember is, all the while this is going on, it's also pulse charging the start battery. As you can see on the right, the auxiliary battery system is fully charged, resting just a little above 13.1 volts. On the right, the start battery is fully recharged and it's been pulse charged right there. It's sitting at 12.75, and this is what it looks like when the system backfeeds or pulses the start battery.